we're standing in the Center for Innovative Material Processing through Direct Digital Deposition, SIMP3D. We've been around for almost 5 years now. We serve as the manufacturing demonstration facility for DARPA, Department of Defense. Essentially, we serve as an honest broker for military service contractors and industry in many ways to sort of try out the technology before you buy it. And subsequently doing a lot of training as well on what is the technology, how do we use it, how does it fit into your company, and then of course, what do you need to know to be able to use this technology and take advantage of it for your products and processes. Additive manufacturing gives you a lot of advantages that you don't have over traditional manufacturing. You can create intricate geometries that potentially you could machine or cast, but you can do them a lot more cheaply and a lot more easily, and perhaps at a lot more finer detail with additive manufacturing processes. So these are a couple of the powder bed fusion systems that we have here in SIMP3D. And essentially within this, you start off with metallic powder of various, couple of different alloys that are available. That's then sort of finer than grains of sand. You pour that into, fill up the hoppers in the system, and then the recoder blade that's inside will scrape that back and forth at very, very fine layers, 20, 40, 60 micron layers, that then the laser that's up on the system here in the galvos will move back and forth. And all that's doing then is melting this powder. It's heating it up enough to melt it, fully fuse it, such that as you go layer by layer by layer, you're then building up that part, hence 3D printing. This is the build plate or a substrate that you build on. You get very, very fine detail because again, you're going very, very small layers on this type of system to create these parts layer by layer out of whatever metallic alloy you're using. This is actually an Inconel 718, so it's a nickel-based super alloy that's used in aerospace and in this case oil and gas industry. And so these were built up in here again on the build plate. It's lighter weight, same functionality and performance. Actually, this is the same type of alloy that SpaceX is using now for some of its engine nozzles that it's 3D printing and testing for space flight. Inspection technologies are critical for additive manufacturing parts. So what you do is the part is actually mounted inside there, and then you will slowly turn that around, taking an X-ray picture of it each time, and then the software will stitch together all those 2D images to create a three-dimensional point cloud representation of your part that now tells you, or you can use that information to check how accurate is your part, are there any defects. So not only is additive changing how we design and how we make things, but it's also making us rethink how we inspect and qualify parts. All right, so this is a directed energy deposition system, sort of the second main type of technology for doing 3D metal printing. In this case, you're still using a powder, or you might use a wire feedstock in some other situations, where you're actually now blowing powder in. You can actually see inside here, we've got these 4 little nozzles, powder is blowing in there. The laser then is running up and down within the system itself. When you turn that on, it creates a melt pool, and then it's blowing powder into that, and whatever gets captured then solidifies to create your three-dimensional geometry.